Hi everyone. In this video, we will look at how to implement a simple agentic workflow that uses custom tools. So whenever you're working on an agentic project, you might find that you want to execute external code outside of the LLM. And if your use case is not that common or something related to your organization, you might find that there is no existing tool that does what you want to do. So in this case, you'll have to write it yourself. So we'll show how to write custom tools, how to give them to the LLM and tell the LLM to use them, how to execute these tools and get the final answer from the LLM. So in order to do this, we will use a pretty fun use case. So imagine that you just started working on a new project and this project contains secret API keys, like the project we're working on right now. So in order to run this repo, you may use either a Grok API key or OpenAI API key, and these keys are secrets. So you usually include them in an .env file, and this file should not be pushed to a GitHub repo. But let's assume that by mistake, this file was pushed and it's now public. We want to create an AI agent that can take a repository URL, download the repo locally and scan it and look for the .env file, see if it's there and if it actually contains any secret. So in order to do this, we will create two custom tools. One of them is going to download the repo. The other one is going to scan the repo. And then we will run them and give the answer to the LLM so that it can decide whether the repo actually contains any pushed secrets or not. So we have the custom tools file, and inside here we can see we have mainly two functions. These are the tools that we will be using. So these are normal Python functions. This is a function that takes a URL of a repo and it downloads the repo locally. So if you run this, if you try to run it in a Jupyter notebook and you pass here a URL repository, what's going to happen is you're going to go to the data directory and you'll find a directory called repo. And inside here, you'll find the actual repository that corresponds to this URL. So it downloads the repo and extracts the zipped folder. This is what this does. And the other one, you give it a directory path and it scans this directory. It looks for a file called .env, and if it exists, it reads the file and returns the content. Otherwise, it returns none. So you can see these are completely normal Python functions. And in order to convert them to tools in LangChain, the easiest way to do it is just to import the tool decorator from LangChain and just decorate your functions using this tool. So now, yeah, you can see these are completely normal Python functions and we are converting them to tools. This means we are able now to give them to an LLM and let the LLM actually interact with these tools, and we'll see how we can do that. And the last function is just called get all tools. It returns a list of these tools, and we will use this function in the other script. So this is the graph that we'll be working with. It's very straightforward. You start by going to the LLM. The user asks a question. That question, either it needs a tool call to be able to answer this question, or the question can be answered directly without anything. So you go to the end node. So for example, the question could be, what is LangChain? You don't need any of the tools that we defined, because we defined two tools. One of them downloads a repo. The other one checks for the environment variable. So they have nothing to do with the query. In this case, you don't go here, you just go to the end node. So let's see how we can implement this graph. So to do this, we're using LangGraph, and we define our state. And the state here is just a list of messages. So we will only be keeping track of all the messages, all the basically the history of the conversation. And we have two nodes, as we showed in the image. So one of them is the LLM node, and it contains the LLM itself, which we defined here. And if you go to the get LLM function, it's basically a function that takes in a string name, the LLM name, and it returns one of these objects. So we can use either chat OpenAI or chat Grok. Now, if you look at the configuration file that I'm having here, I'm setting it to be GPT-4 O-Mini, which means, yeah, at the end, this object is the one that's going to be returned. So, yeah, this is the LLM. Now we bind tools to that LLM and we give it the tools that are returned from this function. If you look at this function again, it's just a list of both tools that we defined. So this means that we are telling the LLM what tools it has, and it's completely free to decide whether to use them or to generate normal language. And yeah, we invoke that LLM on the list of messages that we have, and yeah, we get a response. So before we move on, let's see what happens if we run this. So let's run this. We will start by going into the LLM node, because this is where you go right at the beginning. And we are going to print the response and exit the program. So let's just do this to see what the response would look like if the LLM decides to call tools and if it decides to not call any tools. So let's run it. And I'm going to start by asking a question that doesn't need any tools. So something like, what is LangChain? So you can look at the LLM response. The content is a large piece of text. And yeah, we look at the additional arguments and just contains refusal none, doesn't contain anything else. So that looks like a completely normal response that you would get if you did not call any tools. Now, let's try to run this again, but this time I'm gonna ask a different question. So does this repo contain any pushed secrets? And I'm going to provide a repository URL. So in order to answer this question, you have to use both tools. You have to actually download that repo, and you have to scan through the files and see if the .env file exists, and read the content and decide whether it contains secrets or not. So let's run this, and yeah, we will exit the program after. So we just print the response and exit. So this time the content is empty. So it did not generate like normal text. Instead, if you look at the additional parameters, you see there is a key tool calls, which did not exist in the previous trial. So this time the LLM is telling you, I want to execute some tools. And yeah, the name of the function or the tool is download and extract repo. And I want to execute it using this argument. The repo URL should be this. So it's as if the LLM is talking to you and it's telling you, please run this for me and give me the answer so that I can continue. And this is something that you should know. LLMs themselves, they cannot run code. LLMs are not computers. LLMs are nothing but next token predictors. So you give them a prompt, they predict what the next token is. And that's it. So LLMs cannot run this code, but they can tell you to run it for me. So basically, the LLM is telling you, run this for me. Your job now is to execute this and give the LLM the answer back so that it can continue running. So yeah, just wanted to show you how different the response is going to be if the LLM decides to call a tool versus if it generates normal language. So now we were at this node. The LLM got a question, and we saw how the response would be if we decided to call tools or if we don't need to call tools. And in order to do this rerouting, we will look at the should continue method. So this is where you go after done executing this to be able to decide where you should go next. So what this is doing is it takes the last message, which is in our case the response of the LLM, and it looks if this message has an attribute called tool calls. So in the second try when we asked it about the repo, you can see there is an attribute here called tool calls. So this means we should be rerouting to the tools node. And if this condition is not met, it means we are not executing any call, and we will just go to the end node. Now, if your query required a function call, this means that you will reroute to this node. And what this node does is it takes in the last message, which in this case is the response of the LLM. It looks if this message has an attribute called tool calls. In this case, it does have it, and it's a list of one element, which is the call to the download and extract repo. So it extracts this information, the name of the function and the arguments that the function should run on, and it gives it to the execute tool call. This function is going to execute this and return back the answer. And this answer, we are going to store it in a tool message, and we append this message to our list of messages. So now the LLM sees the answer of running this this call. So you can see we are running this this function locally on our machine. The LLM has nothing to do with running this. So LLMs cannot run code. They can tell you to run things for them. So yeah, after this is done, now we are done with this. We're going to go back to the LLM. The LLM sees the answer, and it can decide whether to call another tool or to just generate an answer. So this is the execute tool call that we used in the tool node. And what it does is it takes in this entire thing. This is the tool call that the LLM needs. It extracts the name, just the name of the function. It extracts the arguments. So we have this here. We get that function from the tool registry, and we invoke the function using the arguments that the LLM gave us, and we just return the answer. And yeah, the tool registry is just a dictionary mapping each function name to the function itself. So if you look at these tools, these are a list of functions. And what this dictionary contains is actually the name of the function. So the download and extract repo function, and it's mapping it to the function itself. So it's just a way to provide the name of the function as a string, and you get the function itself. So yeah, this is what's happening here. We get the function from the registry, and we just call it using the arguments that the LLM provided. So let's do a quick demo. For this, I'm going to remove the exit statement. So let's run a full program now. So let's ask it again, what is LangChain? And we said that this query does not require any tool calls. So you should see that the LLM yeah, it starts giving you text, so no tool calls. Now I'm going to run this on two repositories that I have here. One of them is a demo repo that contains an environment file, and inside of it there is a fake API key. So this is not real, but whenever the LLM sees this, it should be able to identify that there are secrets pushed to this repo. And the other one is a completely normal repo. It does not contain any secrets. So yeah, let's ask it, are there secrets pushed? And I'm gonna give it this URL. So this repo does not contain the .env file. So let's see what happens. So you can see it decided to use a tool, which is the download and extract repo. So it downloaded the repo, and the result of this tool call is the path to where the repo is downloaded. So it was downloaded in the data directory, in the repo directory. If you look here, this is the exact repository that I was showing. And then it decided to use another tool. So it used the inf_content function using the path to this repo. And the result was none, because again, if you remember how we implemented this, If the environment file exists, it reads the content from it. If it doesn't exist, it returns none. So now the LLM is saying that there are no secrets and no .env file in this repo. So let's try to run this again, but this time I'm going to use the other repo. So again, it decides to download that repo. You can see the repo here has changed. This time it has the .env file. And then it used the other tool. It reads the content of this file, and you can see that now it sees the fake key that we have here. And yeah, it was able to answer correctly that yes, there are secrets pushed to this repository. So that's it for this video. The main key takeaway here is that LLMs do not run code themselves, but they can tell you to run things for them. So your job here is to write custom code that runs these calls for the LLM, and you provide them back to the LLM, and it should be able to decide what to do with the results. So yeah, I hope you found that useful, and I'll see you soon.